Okay, welcome back. Let's pull this all together. I want to talk about the next coaches meeting. I want to talk more about stat626 Studio, but I want to share with you an announcement that's very important, near and dear to my heart. I have agreed to be the interim director of the Texas A&M Institute of Data Science, university-wide. A university-wide effort. So in my spare time. So here's the choice. They pick somebody outside of... I want statistics and analytics to be front and centre in this thing. So I said yes when I was asked by the professor. I'm going to give up teaching undergraduate statistics, and I'm already getting messages about how many kids' lives I'm ruining. But I'm going to be the interim. I haven't said whether I want to be a candidate or not, but it's university-wide. You can read the announcement. It's a description of what to do. Foster collaboration across the whole university, whether the big data's in astronomy, in medicine, in business, in physics, whatever. Government, cybersecurity. Just think about it. It's a big effort, but it's a big opportunity. And so MS Analytics will be front and centre in that. We will have a seat at the negotiation table. And I love negotiation. I love to be underestimated. One of the distinguished professors in engineering said, "It's great you've agreed to mind the shop while we go and look for a really big star."
Oh, really?
And man, growing up one of the convicts, mate, good luck, sunshine. Good luck. Here we go. I've got a long memory, mate. 20 years is a short period of time. This is a really positive thing. And I love building things from scratch. I started programs in Australia. I've started 2 programs here at Texas A&M, both of which I'm very proud. So that started on the 1st of November, so I have another job. So this is still my love. In fact, when they came and asked me and said, "What are you going to give up?" I said, "I'm not giving up analytics. I'm not giving up distance ed. I'm going to keep both of those. They're very important." So there it is. You will hear other people's versions of it, but you heard it straight from me. I actually think this is a great thing for analytics because we will be front and centre in that discussion. Would it be wonderful if you go to this data science website and initially you see my name and you see this MS Analytics program, which the link should be there forever. That's my plan. So I'm going to get back wearing suits talking to boring people. But that's okay. Suddenly I'm going to have a lot of new friends. When I was department head, I had a lot of friends. And they went away, and suddenly it's amazing how people have popped out of the woodwork.
Strictly coincidental.
Yeah, strictly coincidental, Jane. So somebody came and said, "What can I do for you?" and asked me for some money already. So there we go. So they're accepting applications for the job early next year. If you think about it, someone might come in September. It might be for the whole of next year. Who knows? Somebody might pop out of their porridge in June. But I'll be doing this, I think, for probably a year.
Congratulations. Dr. Keeler.
Yes.
Do you know what they hope to accomplish with that? Are they trying to start new doctoral and master level programs with it?
That's a great question. So one of the things on the table is a certificate program for graduate students. I would love to see every quant-based graduate student walk out with a data science certificate. So if you have 2 or 3 semesters of calculus and you're from math and engineering or physics, I would love to see them be able to get a data science certificate, which is very different from what we do, right? But again, it enhances everybody's brand. If you look at business schools, MBA, executive MBA, the higher the reputation in one, it drives the reputation in the other higher. So that's one thing. They would like to, the holy grail now. So my spouse is a CFO at another SEC school, and I sit there and listen to the new president talk about interdisciplinary research, because that's what agencies want. The data is key, the data science part is key, but you need subject matter expertise. So it's about getting project groups together, and I'm a champion of senior assistant and associate professors. Dr. Dabney is one of my great, I found him and helped develop him. So that's one thing, and then outreach to companies. I want to run a data science competition for senior undergraduate students and graduate students. Companies can't get enough of the brightest and the best. And imagine you're on the judging panel and got to look at the brightest and the best work. You will, but it will be for a substantial fee. So that should keep me busy for about a year, I think, if I can pull that off. One of the reasons they wanted to have somebody is because there were all of these departments saying, we want this course, we want that course, and one of my jobs is to go and negotiate of what courses get in. So, and I really love negotiation. I'm not joking, if I ever gave up my job, I'd go and sell used cars. It's brilliant. Thank you for the question. Any other questions or comments?
Give him a hand for the, first of all, Dr. Shea.
I'm going to tell our other colleagues on Thursday night in stat626. I mean, you can, but I would rather tell them face to face. All right.
Are you posting that announcement somewhere, or?
I could, mate. Would you like to see it?
Yeah, I'd like to read more about it.
Okay. Well,
Thank you.
We'll get it posted for you. Okay. We have 8-minute updates. Yes, here we go. And you'll see the form is very similar. Basically, we want to hear what's different since last time. We should be doing data and models, and what does it mean, right? At this point, yes, or we're going to have the holiday break from hell. I implore you to reach out to your project coach. I have been sitting with some of my guys, and we have figured it out one-on-one. That's the way this works. And I will help with other people in general, but I don't want to disrespect my colleagues. If someone else is the coach, I ask you to talk to them first. Because imagine if somebody came, if one of my guys went to talk to someone and not me, I'd be a little bit hurt. It would hurt my feelings. These people are my friends as well as my colleagues. All right, we look forward to that. Any questions about how that goes? There's an instruction about when you submit it on eCampus, basically the night before. Yes? And we're all talking about new. I don't know about the other project coaches. I could do the first few slides of everybody's talk at this point. We all know, right? It's like in the US, the last episode's at the end of April. Like who shot JR, and then we have to wait till the fall to find out. We know what you're trying to find, and we're hanging on, did you find it, and what does it mean? Right. Okay, good. So what we're going to do next is we're going to road test very carefully SAS Forecast Studio. So last week we looked at relatively straightforward examples where things mostly worked out. And here we're going to hit the tyres hard and really look under the hood. So the first example is monthly sales tax. I listened to politicians on TV in Texas when I was first here, so it was really hard to predict future sales tax receipts. So we needed to be very cautious, and that in part led to cuts to the university. So that got me really cranky. You know, we get less than 25% of our money from the government. You know, if it was up to me, I'd say, thank you very much, you can have it all back, as long as there were less restrictions on what we could earn and what we could do with it, but I'm not in charge. Anyway, so we want to look at, from 2001 right up until 2016, my bad. This is the drama of I'm changing my notes every year. We want to use up to 2016 to predict this year. And here's the series. there's clearly an increasing trend. There's clearly a level, 1 or 2 level shifts down, right? Around 2009, do you see the level shift?
Yep.
It's amazing how much we've learned just looking visually. And there's kind of another level shift up here somewhere. See how this is kind of trend up? And then it flattens off. Yes?
Yep.
Yes?
Yes.
So, the first thing we're going to do is first difference. Yes? Now, this is a weird looking pattern. Look at lags 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. What is going on here?
Back from saving that.
Seasonality. It's monthly data. Where's the 3, 6, 9, 12? Who owns a small business in Texas? When do you have to submit your sales tax receipts?
Quarterly.
Quarterly.
Jim Whitaker does.
Mr. Whitaker, I'm told you run a business. Do you have to submit sales tax receipt quarterly?
Come on, Mr. Whitaker. Don't leave me here.
Is here? Aaron says yes. So, is the season 12 or is the season 3?
I said both.
Yeah, there's 3. Every 3 months is a season.
It's quarterly, right?
That's the trick. Why would you trick us?
Quarterly.
The pattern there is both, isn't it?
Yeah. Both.
Both. Well, let's sit on the fence and we'll have a pie in one hand and a can of beer in the other. Well, you can't have both, okay?
Why not? Why not? Ah, that's simple, but why not?
You can if you want to get real complicated. So if you have daily data and you want to get to that level, but here, no, I say the season is yearly. Basically, months matter. So if there is this quarterly thing, March is like March. June is like June. September is like September. December is like December.
So even if
That's
the certain
Even,
set of
it's
months
still
looks different
12
than the
months, right?
Right.
Right?
other.
You pay every 3rd month. February is still like February.
Cycle.
Get it?
Yeah.
So I don't think you need to overly complicate this, because basically if you use a 12-monthly cycle, it's saying, what month is this? Let's look 12 months back. Are we good?
Yep.
So, Dr. Shearer,
Yes, Diego.
when we talk about this dual seasonality, I'm thinking about tides. If we wanted to predict tides,
You wanted to predict tides, yeah.
there is a daily cycle
Yes.
and there is a moon cycle.
Yeah, you can get into all of that, and some of my colleagues do that, but it pays really badly, so that's why. Okay? My colleague in particular rides a bicycle who's into the tides. I drive a BMW. But no, I don't know. It's science, mate. I'm the business guy.
But I mean, a phenomenon like that have two
It's
different...
really interesting, but beyond my meager abilities. Okay? I'm just doing business stuff. Yes, you can get into double seasonality, and it gets very complicated. But what is the mantra? If we don't understand the basic building blocks of how to build models, there's no point even messing around with the complicated ones.
Right.
Are we good?
Yep.
Good. So we're going to seasonally differences again. And here's my worry with SAS Forecast Studio, is that it's going to not eyeball something, it's going to look at some test. This guy Dickie from NC State is a great one, fantastic guy. He's one of my friends, but you know, I'm being recorded, so you know my views about tests. So, when we do the double difference, what do we see? Well, a lot of the stuff has gone away, hasn't it?
Yep.
Yes, there are many fewer spikes. But it's really not clear what order you should pick, is it?
Yeah.
Now, another question I get is, look at this lag 11 business. Right? Do we really need lag 11? I hope not. So some of that stuff comes around because of the the seasonality. My experience is if we take care of things, that should go away. I'm not going to stress. I've never seen the need to have 11 lags in monthly data. Okay, so I'm going to be very conservative. I'm going to go up to lag 7. And then this way I'm going to go up to lag 3. So I even went up to lag 8 for the moving average, and I went 3 and 2. 864 models. So you don't want to do this too much because it's slow. You do thousands of models. It's because whatever the models are here, they're multiplied here. And then it comes up with ARIMA 210, 011 and 210012. Yes? They're the two. Not what we would have picked, is it? Yes.
Sridhar, why, can you go back to the previous slide? Why did you say 03 and 02? Can you?
3, because look, at around 36 there was still something. I'm looking at PACFs for ARs,
For the
and
seasonal.
for the MA there was things around 24. So if it's MA, I'm looking at ACFs, so that was 2.
So because the cycle is 12, that's
Yeah.
2 and 3.
Mm-hmm. Yes, Aaron.
If you're going back to the original data, instead of double differencing, I don't know, and you know, like say you want to model Christmas sales because you said you want to compare December to December, why don't you just make a list of like, say 20 Decembers for 20 years and then...
You can do that, that's what we did for the Lion King.
Right.
But that assumes that a December 20 years ago counts as much as last December. Right? So I just have a problem. Look at all of these things that you want to model that all pop out of your porridge. That's a lot of terms, isn't it? And they're pretty persistent. So call me old-fashioned, really. This to go old-fashioned. I want to difference that again. Can't wait to see what SAS Forecast Studio does, can you? I can't wait. But I can drop myself because I won't be able to evaluate its model unless I'm happy with my model.
That's correct.
Is that fair?
That's fair.
So, here we go. 210011, now we intercept minus 0.6, minus 0.4, plus 0.8. Passes the white noise test. It's a beautiful thing, isn't it? Yes? Valid model. Then we put it in the outliers. And look, before you jump on me, I put 0.01 to start. Because I didn't want to do lots of iterations, right? I didn't want to do lots of iterations. Because if you do 0.005 and there's a bunch of outliers, you find 5. You put that in, reduce the standard deviation, you find another 5. Okay. And notice here, look at this. We're still okay, right? We're still okay. The white noise test is okay. We're going to put these 16 outliers in. First we're going to do 210012, and notice that the 012, the MA224 term, is barely significant. It's barely significant. But it passes the white noise test. So we've got 2 models we're happy with, yes? We only find 8 outliers here. This is a little concerning, isn't it?
A little bit.
It's a little concerning. But as we were talking about before with Mr. Cameron, a couple pop out of your porridge and you've got some outliers. Let's put the outliers and level shifts in and see what happens. Could tidy it up or it could make it worse. We've seen both, right?
Yep.
So, if you look, the outliers are very similar at the start. There's a shift at 98, a shift at 171, and a shift at 100. So 98 and 100 are the start of 2009, where we saw, and the 171 is where it flattens off. So I've been using this data for a couple of years, and I look like a real wally, as we'd say in Australia, a real wally. because I was trying to predict starting right at a level shift. So the predictions were terrible. Right? That's why next week we can't wait, because we're going to do transfer functions and have leading indicators. Yes, so here are the two shifts that it finds, this point and this point. Once and twice, and over here. Because this stuff would be expected to keep going up there somewhere. Right? So here's my point. I'm hoping SAS Forecast Studio finds at least those. I'm not fussed about adding some outliers, but those level shifts seem important, don't they? Yes? They seem important.
Isn't there another one at December 2015?
December 2015. I'm not sure.
Well, the graph, the SAS had it.
There's a bunch that pops out of that porridge, Sam, yes. But they're the ones that are across both models and look really big. Now, this is a beautiful thing. Have a look at the white noise once we take into account of the outliers and the level shifts. It makes me weep with joy, right?
That's happy.
And wasn't it fun in that presentation today when he just changed the thing to SBC and suddenly we have a valid model? Hallelujah! People were singing in the streets.
They were.
Yeah.
The angels were humming.
Right. So that's a pretty good looking model, isn't it?
They did great. It's a
Yes.
good looking model.
And you'd imagine that sales tax should be relatively straightforward. So what does it do? There's the seasonal term, so it looks back 12 months, a moving average. Right? If we're in October, we're in November, it looks back at last November. And then for the non-seasonal part, it's AR2. We're in November, what happened in September and October? So recent plus what happened 12 months ago. Makes a lot of sense. And here are our predictions. The graph looks pretty good. Notice we get down the level shifts. And here are our predictions that we're going to live or die with. This is a methodology we know and love, right?
Yep.
And I'm very proud of the fact that we get taught this in this class. And there are not many books that have this stuff. But we have this cogent way of building valid models, right? Good. Then if we look at we have to do 2 iterations with the other one. We end up with 12 outliers. The code is on the website. And again, we get a beautiful white noise plot. Yep. We get a beautiful white noise plot. This AR2 coefficient, the MA2 coefficient, yeah, this MA2 coefficient here is pretty statistically significant. So I couldn't control myself. Guess what I wanted to do at this point? Compare SBC. 1921 and change with
That's better.
1917 and change. So which is the better one?
This one.
This one. They're pretty similar, aren't they?
Yeah.
But if you had to pick, yes, we had 2 valid models, and again another set of predictions. Cameron.
So in Forecast Studio, when you're defining or you're setting the premise for outliers, you say a maximum of X% of the data.
Uh-huh. Or a
What's
maximum
your
number.
kind of rule of thumb as far as like percentage of the data? How many are too many outliers?
Well, that's the thing. I always investigate the data first before I use SAS forecasting.
Well, I'm talking about even doing it this way.
Yeah, so 10. If you've got more than 10% outliers, you've got a problem. So, here we go. Let's compare the forecast and the errors. The actual is the red. The green is the 210011. And green wins, green wins, green wins, green wins, green wins, green wins, blue wins, green wins, green wins. Now it's only 10 months, but the simple model with the smaller SBC wins. And what are we off? we're typically within just a couple of percent, right? A few. So I mentioned you could say to the folks over in the capital, I can tell you a year ahead, up to a year ahead, what your sales tax receipts are going to be. So within 5%. That's pretty good, isn't it? Yes? So we're happy with our model. Let's see how Forecast Studio does. Okay? It's a pretty, it's a medium difficulty one, right? We found the model. It didn't look too flash, but when we put the additive outliers and level shifts in, the white noise looked good. So, Texas monthly sales tax, the time is month, sales tax is the dependent. We're going to look for 10 outliers. See, the other thing I wanted to ask, but I didn't want to get into a big public brouhaha, is I suspect, well, I'm pretty sure that I figured out that if you put 20 there, it's harder to detect an outlier if you put 10, because it becomes it's trying to predict the multiple testing against the problem of multiple testing. And notice too, I'm going to raise the significance level to 0.1, which I do not recommend, but just for illustration.
Okay.
Not 0.05, but I'm going to look for 10. I think there's 4 or 5 really important ones, and there's a bunch of others. And I want to make sure it has every chance to catch them. So the overall significance level I put at 0.1. You know how you saw the edit settings? You can change that and watch what happens. Are we good?
Good.
We're good? And we're going to push our friend SBC.
Not Matthew?
No. I wish I could pay extra for a version that didn't have any of that stuff in it.
R-squared?
Well, there's one that's got R squared in it. Shoot me now. Sorry?
Why do they have it then?
Well, who knows? You know, not everybody agrees with me, Aaron. It's ridiculous. It's ridiculous.
So actually, the software has a random walk R-square. What does it mean?
It means if you're trying to fit, it's trying to maximize the R squared for a random walk process.
Because I noticed it was smaller.
Yeah, look, I don't know.
I mean, he's pushing his buttons.
There you go, trying to wind it up. Don't wind it up. There you go.
You know, when I go into a fine wine store, I head over to the fine wine section and I look at the stuff, typically under a lock and key behind the glass. I don't go and look at the cheap $3 bottles. I have no clue about it. So that's
Do you make them unlock the cabinet?
Yes, I like the lock cabinet myself.
Don't even ask the question about it.
So, have a look. How did we do, guys? I think we did pretty well. You saw when you looked at some of their things that I knew we were going to have some problems with the white noise probabilities because the series, the dots, and the segments didn't match at all well. There are a few outliers it doesn't catch. Right?
Is the model valid?
Yeah, well, we're going to find it out.
Oh, not bad.
Not bad. Not as good as we did.
No, it's not. Yeah.
No.
How many outliers did it pick?
I don't know. See, there's all those things. Now, I'm just looking through the screens. Well, it picked 4 outliers.
Okay. Level shift.
It did regular differencing and seasonal differencing.
Yeah, they do that.
Yes.
Yeah. That's good.
And it picked 210011.
That's the same.
210011. Hello, that's what we have.
That's what we had.
One of the one.
So we agree on the model.
Yep.
Yes? But I feel a lot better about their model because we fit it first, right?
The SBC is lower here.
Yeah, again, you've got to be careful because they'll have different definitions of SBC depending on whether they want the coefficients.
Okay.
Whether they want the constant term.
Okay.
So,
What Deborah was saying. Come on, girl.
it found a level shift in March 2015, and it found a level shift in February 2009. So it found 2 of the 3 level shifts that we identified, that the others identified. And see, notice, so this is my experience. When we do the ARIMA modelling that we know and love for the whole semester and do outliers and level shifts, it's doing each one of those at the level 0.005 or whatever. What this is doing at an overall test, because notice these p-values are really, really small. But it's saying, having taken those together, it doesn't find anything else. So my experience with SAS Forecast Studio, it doesn't find as many outliers and level shifts as you would expect. So if we look, it used conditional least squares. We used maximum likelihood. Now we could have changed ours to conditional least squares. We could have rerun theirs as maximum likelihood. It makes sense if you've got an artificial intelligence thing to use CLS, because CLS converges much more often than maximum likelihood. Yes?
Can we change it in jump?
Can we what?
Change it in jump?
No, it does maximum likelihood. Have to go.
210112, I was expecting to see AR1 on the seasonal coefficient also.
Ah, so maybe I've written the wrong thing down. So there's 011. I was at a conference doing my class notes.
Okay.
Typo, my bad. Every year I update, so every year I get my typos. We good? Now,
Out of class 2018. Started in 19.
the estimates are a little bit different. The MA 12 term, 679, 555, minus 0.63, minus 0.60, minus 0.36, minus 0.32. It's this MA terms a little bit different, 0.68 versus 0.56. And you can see it found April 2004, it found 215.5, or we found 223.7. It found February 2009, we had minus 126, it said minus 151. So it's pretty similar, but it didn't do as many as we did.
In spite of 0.1.
0.1. 0.1. Right? In spite of 0.1. You can monkey with that yourself. Then there are the forecasts, and let's have a look. Is there really a big difference between the Forecast Studio and ours? No. Well, so the real is red, and the blue and the green are the forecast. They're very close. Something weird happened around here, didn't it? Didn't follow the seasonal pattern that we're used to. But, you know, we don't have that luxury, do we? If we were doing this in real time, we would do May, and we'd be, you know, patting ourselves on the back. So, we start the year well, we don't do so well in February, we do really well in March, we do really well in April. May, we're kind of okay, then we do terrible. So we would go back and look at that point, right? Refit the model with it. And then we don't do so well in July, we do terrible in August, terrible in September. Something's happened here. Right? Something's happened. It might have been a rule change or something, I don't know. But what would we conclude? That Forecast Studio and what we do came up with a pretty similar model. Right? I like ours is better when we look backwards. Right? Within the series we get closer fits, but going forward there's not a huge difference. Right? Are we good?
Yep.
But I feel much better about that because I fit the first model. I'm not at all confident until I do the steps that we know and love. Okay? let's look at residential electricity consumption. So one of the groups is doing electricity bills, right? Electricity bills. This is across the whole of the United States. And this little series, oh man, this is tricky. And every year it gets trickier. It looks really innocent. It's like the friend you get in college that turns out to be really interesting. Your parents say, what are you doing knocking around with them? So, look at the series. What do we see? We see seasonality, right? We see increasing mean and increasing variance. Think about 1990, there was much less consumption. The variability was much less. So we got the whole 9 yards, haven't we? Non-constant mean, non-constant variance, and seasonality. We try a log transform, and what happens?
Better.
It looks beautiful, doesn't it? Yes, we still see the seasonality. Look at the Christmas trees. Yes? And they don't die out at all, do they? And we've got an increasing trend. So we're going to first difference to get rid of the increasing trend. And notice what we do to the Christmas trees, we flip some of them around. Now, do we need to seasonally difference this data?
I'm not sure.
Oh, are you winding me up?
Yeah.
No, seriously.
Yes.
Does the seasonality die out?
No.
No.
It's persistent.
It's persistent, right? You can do more than 40 lags, I just couldn't fit it on the one sheet of paper. So I want a difference. And we end up with this. Now, how does that look? It looks a lot less complicated than the previous one. How many significant lags do you have in the ACF and the PACF of this one? A lot, right? Now, race to stationarity means that we get a simpler model, the double difference, yes? Now, I'm going to say the seasonal part looks like MA1 because at 12, then nothing much at 24, and nothing much at 36. There's that 35, so I'm not convinced. What about the non-seasonal part? Not sure, right? Not sure.
MA2?
Yeah, maybe. Now,
No, not sure.
curious, I've got the intercept on here. Well, we do double difference here. It turns out the intercept is significant. You actually get better results with the intercept. Models are more stable. The white noise behaves better. Something weird going on here.
That's on the double difference.
That's on double differencing. I know, JT, it should theoretically cancel things out, but it doesn't.
Okay.
So sorry, what happens in when you see lag 10 and 11 popping out? Typically, what do you?
There you go. What happens then? It's like,
It's happening on our project.
yeah, and then you watch. It will go away if you get sorted the lower lags. Think
Okay.
about the one with the sales tax. Lag 11 popped out, and we needed what? 210011. Okay.
Dr. Shiva,
Yes.
just to confirm, why did you pick AR and MA orders of 3-3 on the seasonal?
The seasonal, I said, look, here, this is close, and this is close, around there. I just want to be conservative. I don't want to end up to being, it picks 2 and 2, and then I have the white noise thing, because this is going to run 400 models. Okay? I was literally doing this yesterday. Right, I had a plan, I had last year's data, I was just sitting here doing it.
And you picked 4 and 4 on the non-seasonal because of
Because of, look at this 4 here.
4-1 here. Okay, that's the ACF.
So the PACF has a
Yes.
4 pop out of your porridge, so I just wanted to be conservative.
But on the ACF you don't have, you could have just done 2.
2, I could have,
Okay. I just want
but I want it to be a one-shot go.
Okay.
Now, look what happens.
No.
Oh, so you should look at what it picks. It picks 111, 011, and 112, 011. Here's 111, 011. Look at the intercept. It's very small, but it's significant. And then look at the white noise. This makes me weep tears of sadness.
Yep.
There are 5 of them.
That's very low, right? Or is it because it's seasonal?
There are 4 of them, right? 4 of them. Yes?
Do we worry about them?
What does that mean? What does it really mean?
Well, that's what we're going to discuss now, right? It's this group. Every time series I've updated, something's popped out. This didn't happen last year. Somebody kicked the time series black cat. Now,
That's how we roll.
if it was really white noise, 1 in every 20, right, could be significant. 2 in every 40, but we've got 4. And they're just significant. So I'm going to say there is some doubt. Maybe there's an outlier, maybe there's a level shift. I didn't see any level shifts. Yes? When I put the intercept back in, this looked a lot better. Without the intercept, there were more white noise problems. Now, 112, 011. The 2 coefficient for the MA is barely statistically significant, 0446. And how many here do I get?
7.
7. Not what I expected. We put in another parameter in the model and we got worse white noise. So, what we're trying to do is stick a square peg in a round hole. We're saying this is a reamer, and it's probably not exactly a reamer, right?
Nope.
Yes? Even though a reamer is flexible. Can't wait to see what Forecast Studio does. I just can't wait.
Come on.
Okay. When we look at outliers, we find 1. And then when we look at that test in SAS, which is tougher, what do we see? Not good news, right? Not good news. So this little series, right? This little series is tricky. It's aggregated across all the states. You'd think that it would be even better behaved. Maybe there's been a change. Maybe Puerto Rico was added at some point recently. Again, I don't know. Maybe the definition of it changed. So I know when I was doing Netflix, I couldn't get a model to fit when I did worldwide revenue because it started off US based only, then it had Canada, and then it had Australia, Germany, Europe. You can't get one time series to fit what's 3 or 4 processes. They don't start.
Dr. Sheether,
Yes.
I have a suggestion since I do energy forecasting.
Yes, sir. Please help me out.
Maybe some energy efficiency variable. I found that in our territory in the Mid-Atlantic region, lighting efficiency has been picking up at a great pace.
Okay. LED lighting. So that's a predictor.
Smart houses.
And I know in California and Arizona, so if it's for the total US, distributed generation is another thing. So they won't actually be consuming by the utility standards, even though they would be producing and consuming.
Right. But again, I'm thinking about these things are going to evolve slowly over time.
Right.
So it's a bit like Netflix. More and more people watch it. We can cope with increasing and decreasing. We can cope with decreasing cab fares. So it's really a one-time change where you add something to it that usually monkeys with this. Okay? So what do you guys use for your forecasting models for consumption?
We use a DER, so a distributed generation variable for large customers, and then for residential we use efficiency, weather is a big one. And then usually the number of billing days, but that probably is going to apply here.
Right, so that's down at the individual level. Good. And what do you model the time series errors at?
What model?
Yeah.
Right now we're using linear regression because I can't have the same problem when I tried to model it with ARIMA, and the linear regression actually performed better.
Yeah, so can I respectfully suggest you do the linear regression and then try and ARIMA on the residuals?
Yep.
Good, thank you.
I did this back in June, so.
No, I know, it's a great discussion, there you go. All right, we do it with 0, 1, 2. This is slightly better maybe. Still not flash, it finds the same additive outlier in February 1999. Not a big deal. Yes? So let's see what Forecast Studio does. I have high hopes.
Hey, Dr. Shea, I got a quick question.
Yes, JT.
So, on slide 37, you made an account for the additive outlier.
Yep.
The white noise got better, but it still showed that same observation as an outlier.
It still knows.
No.
So I haven't taken account of the outliers yet. I haven't taken account, I just identified.
Okay, all right.
And then the next one I used a different model and found the same one.
Okay.
Because here's the deal, we can do user-defined models in SAS Forecast Studio, and I'm going to be able to say, instead of writing all this code, put that as an outline. That's a beautiful thing. Yes?
Yes.
So, the usual drill, sales of megawatt hours. We can log transform, which is great because it'll give us the predictions back on the original scale. I'm only looking for 3 outliers, and I'm going to do the ridiculous thing and have 0.1 as the cutoff.
Excuse me, Dr. Schiller.
Yes.
On that screen.
Yes.
We had a question in the team. It says the median. We were wondering what that meant.
Yeah, so when you log transform something, right? Imagine the distribution is skewed, and you log transform, right? You make it symmetric. You can't go back from the mean to the mean, right? So on the log transform symmetric thing, the middle of the distribution, the mean equals the median. When you back transform, you end up estimating the median.
Okay, understood. So if we did not transform it, that could have been mean.
It could have been the mean. Now, if you're willing to assume the normal distribution, there's this horrible formula which gets you back.
Okay.
To the mean. Okay, Schwartz's, here we go. SAS Forecast Studio. It finds exponential smoothing is the best model.
Imagine that.
Not happy jam,
No.
as we say in Australia. Not happy jam. Did you ever see those commercials, not happy jam? Probably not, you didn't grow up in Australia.
Oh!
Oh, that's a
Broke
fence.
my eye.
That's a fence.
Whoa. Stop.
You're in jail. It's an offense.
It's an offense.
Don't come back.
It is offensive, is fit, right?
Stay home.
So, again, you can't park your brain at the door, right? You've got to know how to drive this thing, yes?
Yeah.
Yes?
Cold.
So, what it did was it had a level weight and a seasonal weight. Seasonal weight meant it did seasonal exponential smoothing as well as the level. Right? It's like the ARIMA part is the first, the level, and it's tacked on another ARIMA part equivalent called the seasonal part. Now, here's the ARIMA model based on SPC.
Still not a fan.
Oh my God.
I thought we were a bit dodgy, but this is terrible, right? And then it says after about lag 24, don't bother even thinking about the model. Yes?
Yes.
Yes?
Yes.
It's a little naive series, isn't it? I can't tell you how many I had to look through to find something that's interesting. Now, Here's what it did. 211200. It did not seasonally difference.
That's the problem.
Go back here and look at the Christmas trees
Yeah.
and tell me you don't want a seasonally difference that data.
How could you
Don't
not?
mean
I don't care what the Dickie Fuller says. I do not care. I don't care if it's been cited 28,000 times. I don't care. Don't you want a seasonally difference that?
I absolutely want to.
And if you were tempted not to, just come back here and have a very close look at this rubbish. Right?
Torture. Torture.
Because you didn't seasonally difference, the Box-Lyon test is lights out for the larger lags. Yes? Good. Okay, you found February 2000 as an outlier. We found 1990 something in 1999.
Yeah.
So, here are our coefficients. So, let's do our user-generated model.
But doctor, it doesn't even matter, right, what the coefficients are?
No, well, I just put them there for completeness.
Okay.
When you have rubbishola, you have rubbishola, right?
Yeah.
Yes, do not pass go, do not look. Now, what I wanted to do, and this was just for practical purposes, I didn't want to write the code with the additive outlier, so you can have a user-generated model and easily add the additive outline. I can show you how to add events like holidays, Thanksgiving. And you watch what happens, it's just makes me smile every year.
That's good.
So we do all the whole 9 yards. We go create and fit a new model, ARIMA. We tell it what it is, and I put ARIMA 111011112. I can't have commas or parentheses because SAS chucks a spaz and says that's not a valid name. 111011, and I force the intercept because that's what we had. I look for outliers, and then I can define events. So I go here to this thing called events, when I'm defining the model like he did. You then go and select a new event, you find the event on the calendar, and you push go. And it says here it is, where that spikes up. So then you push, and how does the white noise look?
Slightly better. Still not good.
Not good, but better than.
Better than terrible.
Yeah.
Better than that last friend you brought to the house, son.
That's
Right? Yes?
You got time over it.
Yes?
Is that graph that you're looking at the same one that's on the right?
Yes.
Okay.
This is the big version of that one, Sam.
Okay.
So it's not flash, is it?
No. No.
It's a lot better than the one we had, which says after lag 24 we've got terrible. Yes?
Sure. So Dr. Schiller,
Yes.
so you either let the software automatically pick everything or you specify the model. Is there a middle road where maybe you specify the differences but it finds the order for you?
In theory, yes. In theory, but I don't know exactly how you do it. So you heard our friends tonight from SAS. They say, look at the manual. I put the manual up online.
Yeah.
Good luck with that. Right? The guys that write the code, it's like they're protecting their grandmother's secret treasure map. But here's the piece de resistance. Look at the look at the ARIMA model that we generated. The SBC is 9537, which is better than their ARIMA model and better than the smoothie model.
Beat the pants off.
And it's not close. It's like hundreds better.
Beat the pants off.
So, this quite extraordinary, isn't it?
Extraordinary.
Now, when you talk to their guys, and one of the big developers is coming to SAS Day next year, brilliant fellow, brilliant fellow. He says, look, but this looks up collections of models. It doesn't fit every possible one. It looks through the model collection. So if you work in a specific industry and you figured out these are the sort of models, you can put this model in the model collection and it will pick it. But the point here is you have to read very carefully to find out it doesn't fit all possible models. It's not doing an ARIMA model group. It's finding the best one from a long list. So you should be careful, right? You should be careful. So I love to use this product, but I only use this product in conjunction with using the computer on the shoulders. Right? Yes?
Yep.
And here it fitted the additive outlier for February. And then if we look at the forecasts, for some points they're really not that different. For others they are. But I don't think we just don't have a decent model there, do we?
No.
Right? We used the technology the best we could with ARIMA, and that doesn't quite work. There's something else going on. I don't want to find out because I love using this example every year. Yes?
Did you, in this case, did you use 0.1 as the...
Yeah, I've used 0.1 as the cutoff. But there's something going on with the way they have added up the electricity consumption across the states. Maybe there was a change in definition. Good. Barry?
I'm surprised with such a terrible white noise test that the forecasts are not that bad.
Well, we can do okay over a few periods. You know, exponential smoothing is always going to do okay for a couple of periods.
Sure.
Right. But what I worry is if we did this every year, there'll be some years where we're just terrible. Because you know that we haven't really modeled the underlying thing.
Yeah.
There's some aspect, one or more aspects there that's in the porridge that hasn't popped out yet.
Not pop.
Yes, Sam.
So how would you explain the fact that it starts out poorly and then it converges back to a better prediction?
Stuff happens, mate.
But it's not like a function of the model. I mean,
No, it's just the way it is. We've looked at predictions the whole semester. And I hope I've shown you don't want to bet your house and your future life savings on these predictions, right? Yes?
Dr. Sheeler,
Yes.
I've found this in my forecasting as well with the electric data in our area. Over the last 3 or 4 years, if you look at the forecast people have put together, some years are really good, some years are really bad. And so that's where they're kind of trying to really push to find out what's up with it. But still working on that.
Right, thank you. I mean, we don't have weather data. So the first thing you know is the United States are not united. It's really hard to fit the models to the whole of the US. Whether we're talking about turkey sales, whether we're talking about social security applications, whether we're talking about housing starts, and here about electricity. So, but I just use this as a good example. We would have been much better to use the program to fit a model for every state separately, and then aggregate those up.
Yeah.
Yep. But again, I pride myself on the fact that I show examples where things don't work. Because you learn a lot more out of failure than you do these tricked up examples in books where they always work. Yes?
You mean like using the SAS help file as your data set?
Yes. Okay, I want to show you one other thing. So I put up a talk that I gave at SAS Global Forum in 2016. And this was New York City taxi data up to 2015. fare revenue. Now, daily data is the holy grail. If you're in the retail business, you want to predict tomorrow and next week. Yes? Now, have a look at that series. What do you see?
Level shifts, outliers, outliers,
There's a lot of outliers. Look at this level shift. What happened then? They raised the fares for the first time in 8 years. What about these jobbies?
These are all holidays.
Is that September 11th?
Weather days?
Some bad weather or holidays.
2011.
So, this is out of the TLC. A lot of people send in emails, freedom of information requests, including a professor from Texas with an Australian accent. So now they put up the data online for free. So, fares went up on September 3, 2012. That was the level shift. Hurricane Sandy was October 29, 2012. Hurricane Irene was August 2011. The blizzard of 2015 was January 27. Lots of outliers. Yes? What happened up here? Most of the outliers are the negative direction. Log transform is not your friend because, you know, the log of those really small values is going to make them worse. Yes? So, we use SAS Forecast Studio with SBC. We add a bunch of events. So if we go back to the event thing, so if you go here, change other forecast settings, you can go to events and you can add an event. And then when you add an event, you get a name. This is Hurricane Irene, and you can click on add. And then this comes up, you can type in a date, select a date, August 28, and push right arrow. Isn't that sweet?
It is.
With your own name. Now, imagine you want a Christmas Day. If you click Christmas Day and click on the arrow, it puts in whatever you want, an additive outlier or a level shift, you choose, for every Christmas Day, every Thanksgiving. So that's really wonderful if you've got retail data. Yes? You don't have to be going and looking up when Thanksgiving was in 2015. Are we good with that?
That's nice. Good, good.
It's nice.
Like it.
So there's the level shift that we did with the fare increase. There are all the holidays I put in, July 4, Labor Day, Memorial Day, New Year, Thanksgiving.
Excuse me, Dr. Sheeter.
Yes.
When you're putting the events, there is the possibility of a ramp and a temporary change. That's like several additive outliers where the effect fades with time. I mean, do you really use that, or?
So a temporary change would be like the hurricane that hit Houston. It didn't just last one day, right?
Yeah. But if you wanted to do that manually, since the effect dampens,
Yeah, you'd have to look up the manual and see what the definition is. Some kind of exponential thing down.
so we'll have to design a series of dummies with smaller weights and.
You could. You can look up whatever the formula is.
Yep.
I typically, if you're going to do this outside of Forecast Studio, it will put additive outlines, and you're not going to get killed for a few extra parameters. So I typically only use the pulse and the level shift. Right? So, use if significant, and then if you have a look at the forecast, how do we do? They're going down. We did pretty well though, if you look at it. Yes? If you just look at the difference between the lines and the dots. There are our forecasts and the actuals. They look off a lot, but not if you put lower and upper intervals on them. We get the overall pattern, right? The day of the week pattern.
Pretty good.
Yes? And then, this is really weird. How do we do with the white noise test?
I see.
Hmm.
There's no white, there's nothing.
Either that's really good or really
There's no
bad.
fence.
So small that it doesn't pop up. I don't know.
That's good. That's really good.
Do you believe that? If you believe that, you believe in the tooth theory, right?
There's no tooth fairy.
Now,
So why did he do that? What's the...
well, it's saying that he believes that those things are really, really small. That this model is fabulous. 313101.
Doesn't sound
It
bad.
didn't do seasonality. It didn't say Monday was like Monday. It said, if you want Mondays, look at yesterday's. Don't believe that either.
Is that a scale thing, or you might, it's just not seeing it?
It's again that Dickey Fuller test, right? Now, I gave this presentation at SAS,
So you have to be careful.
so I was careful. I didn't show any other diagnostics, did I? And given Dave Dickey was sitting in the front row,
Dickie, right in front.
and he's a good buddy of mine,
Dickie was
we
right
were
in front.
good.
Right there in the front. Dickie.
It does actually well if you think of the forecast. Hurricane Sandy cost more than $2.6 million. Right? Now Hurricane Sandy cost $4.2 million. The blizzard of 2015 cost $2.8 million. Christmas Day cost $1.25 million. These are really interesting, aren't they?
Mm-hmm.
Yes?
Really?
Dr. Sridhar, can you go to the previous slide and, no, the one before, yeah. So seasonality is 7, that means it's taking
It's checking for
Weeks.
Yeah, day of the week.
day of the week.
Mondays like Mondays, Wednesdays like Wednesdays. But it didn't do a big D. Big D equals 0.
Yeah, but what does that small p mean then?
So this is saying I want to look at the last 3 days. So what? Today is Tuesday. I'm going to look at Monday, Sunday, Saturday.
Okay.
Right?
And then I'm also going to look at the Monday.
I'm going to look at a Monday a week ago in terms of AR and MA. But that seasonality dies out. I'm being taped. I say nothing, Your Honour. Look at my face.
So Dr. Shearer,
Yes.
a few classes ago we saw those gap models. Is this equipped to find those or no?
No. No. I think you could be, if you were tricky, you could put them in the collection, but I don't know how.
Okay.
Excuse me, one more question, if I may.
Sure, just one more question. I should get paid by the question. Jones, if Jones had got paid by the question, he would have been a billionaire.
Retired.
Not by the slide, but by the question, right? Yes, Barry.
Can you go to the next one, where we had this model? No, this one, yeah. It may be a stupid question, but I guess if you have a seasonality of 7 in this case, it would never make sense to put a small p of 7 or something.
That's right, you can only go up to 6.
Okay,
Yes.
okay. Just wanted to check.
Yeah, that's
Good
why, actually, that's a really good idea for an exam question. Thank you very much.
Thanks,
The
Barry.
P and the D can only be 6?
And in retrospect, that was a stupid question.
And now, we're going to look at taxi trips.
And then also one.
We looked at dollars, now we're going to look at trips. Yes?
Okay.
And here's the actual and the forecast. It does pretty well, doesn't it?
Yeah, exactly, yeah.
There are a few outliers it doesn't quite find. And again, it puts big D equals 0. Yes, big D equals 0.
Sounds cool, sir.
So, I have a class exercise for you. You don't have to hand it in, let's be clear. I've given you the New York City taxi data up to May 2017. We're going to start at the start of 2013 after the last fare increase. Okay? And I want you to look at the trips. So you're going to start in 2013, you're going to start here. And it's going to go across to 2017.
Okay.
And I want you to come up with predictions for June. Now, this is as hard as it gets. Daily data in an environment that's grossly affected by weather, events. So Donald Trump winning the presidency and they closed off half of Fifth Avenue for months. I know that that had an effect on taxes. Yes? Yes?
So when you're dealing with daily data, is there a way in there to account for only weekday data, so something that only happens during Monday through Friday business transactions?
That's a really interesting question. So if you think about Thursday to Friday, is that the same as Friday to Monday? No.
You close
You can have a dummy.
But you
for
can do a
weekend.
dummy.
A dummy for weekend.
Well, you don't have any numbers. You know what I would do? I'd put in 2 missing values.
Oh,
For Saturday and Sunday.
Monday, Tuesday, Wednesday, Thursday, Friday, Saturday missing, Sunday missing. Monday, Tuesday, Wednesday. Because you can't compare Monday to Friday, can you? That's what I would do. Or I'd aggregate it to weekly. A lot of people aggregate it to weekly. But if you think about cabs, a lot of drivers just drive odd shifts, right? They want to try and keep that cab on the road all 24 hours. So daily is a metric. Even shifts is a metric. But if you're an owner and that's your cab, you want to know.
There's an option, I think, that in Forecast Studios that says weekend. Is it possible that handles that?
Good point, I don't know. So I thought I demonstrated tonight I knew Forecast Studio better than some of the people that programmed it.
That's a safe assumption.
And this is my 3rd year round. You guys are the toughest audience, and, and your predecessors have kicked the tires pretty hard, right? So I'm not sure. Every year I do this, I get out the manual and try and read more pages. And that bloke, he sees me coming and he starts running and he's not a little guy. But again, I think it's really fun as a backup for logic, right? Now, next week we're going to talk about transfer function modeling. If you remember Mr. Rubenstein, he said whether we have denominator models and numerator models, we're only going to learn numerator models. You'll see that that's complicated enough. But if you have a good handle, it's really interesting to see what Forecast Studio does in that regard. You can do transfer functions in there. Okay?
And the breakout exercise, are we only to use Forecast Studio?
No, you can use whatever you want. Well, it says use Forecast Studio, but if I was you know what I would do, JT?
I know exactly.
I'm not opening up Forecast Studio until I've had a little play with it, right?
There you go.
Is that good?
Yes, sir.
So, let's do that for 45 minutes till 9:15. I want to wander around the groups about group projects. I know one of the groups sent me a new data set that I want to go over with them. Does that sound like a good plan? Yep. And next week, come prepared. We're going to be wild and do this transfer function modeling. We're going to pre-whiten data.
Pre-whiten.
Pre-whiten it.
Nice.
Okay. Thank you.